A positive feedback loop is when a result continues to increase and amplify as an event goes on. Climate change represents a positive feedback loop as the warming of the Earth accelerates the warmer it gets. For example, when ice melts, it exposes the darker colored Earth and ocean, which absorbs more energy and increases the Earth's temperature even more. Industrial smog is formed from sulfur dioxides and particulate matter. Industrial smog occurs in foggy, cool weather. It is common in the British Isles. It is grayish in color and most prominent in the morning. Photochemical smog is made up mainly of volatile organic compounds and nitrous oxides. Photochemical smog occurs in hot, dry climates and peaks at midday. Cities with photochemical smog are Los Angeles, Tokyo, and Mexico cities. Many of these cities are surrounded by mountains that act as a bowl to contain the brownish photochemical smog. Recently, we have had some of the warmest years. Since 2001, 15 out of the last 16 years have been the warmest years on record. It is expected that global temperatures will increase at least 2.7 degrees Fahrenheit by 2100. Unusually hot summer days are becoming more common and the nightly lows are increasingly warmer, meaning there is less cooling off at night. Increasing Earth temperature leads to increased evaporation and precipitation with an increased capacity to hold water in the atmosphere. Many places have been wetter than historical averages and have had more record-breaking days of rainfall. In areas that are far away from storm tracks, there will be increased risks of droughts. The intensity of precipitation events will increase on average with more large rainstorms in a single day. Sea levels rise because of two reasons. One is from the melting of land ice, and the second is from warming seawater that expands. The global sea level has risen 8 inches since 1880. This map shows the sea level changes in the United States from 1960 to 2014. It is predicted that sea levels will rise 1 to 4 feet by 2100. Coastal areas are at risk, as Venice, Italy experienced during major flooding in 2008. Many low-lying areas will flood more frequently and some areas will become submerged completely. Increasing temperatures have led to a decrease in global ice. Ice is reflective, which keeps our climate mild. But when the ice melts, the darker Earth's surface is exposed, which absorbs more sunlight and increases Earth's temperature. Once a glacier starts to break down, the melting water only leads to even faster melting. In Greenland and Iceland, there has been approximately 287 billion metric tons of ice lost per year. Just since 2000, Greenland has lost 739 billion tons of ice. Photographs of Arapaho Glacier show the melting that has occurred. Arapaho Glacier is pictured in 1898, and it was later photographed in 2003. Arctic sea ice, when measured during the summer, has decreased by 13.3% each decade. In Antarctica, there has been 134 billion metric tons of ice lost per year. The warming water has caused ice shelves to thin at a faster rate. Many plants and animals are and will continue to be affected by climate change. When coastal wetlands are flooded with saltwater, habitat is destroyed. Habitat will also be lost in areas that are not cold enough. Plants will also not be able to grow in areas that are too hot. If Earth keeps getting warmer, up to 1/4 of all plants and animals on Earth could become extinct within 100 years. If the temperature rises just 3.6 degrees Fahrenheit, we can expect wildfires in the western United States to burn 4 times more land than they do now. Many coral reefs have died off from warmer waters causing coral bleaching. Coral bleaching occurs when algae inside the coral dies off and is no longer a support to the coral. Over 90% of the Great Barrier Reef has experienced some level of coral bleaching. Scientists use proxy indicators to indirectly measure and determine what the climate was like thousands of years ago. One proxy indicator is ice cores. The air bubbles within the ice cores contain tiny samples of the atmosphere in the past. Scientists can determine greenhouse concentrations and what the temperature was at that time. Another proxy indicator is tree cores. Scientists use the tree cores by looking at ring widths. Varying widths of the tree ring show how much the tree grew each year, relating to the change in temperature and precipitation. Pollen is used to determine what types of plants were growing at a certain time. Based on what plants grew, scientists make inferences about the climate at that time. Another proxy indicator is ocean sediment, which is used to determine the surface water temperature, salinity, and nutrient availability. Coral forms seasonal growth rates that scientists can use to determine the temperature of the water. All of these proxy indicators are used to determine what the climate was like thousands of years ago.